Thanks, Kenny, and yeah, very happy to be able to join this group and to talk a little bit about the requirements for design for additive manufacturing. The I want to actually start by saying how delighted I am that that this network exists and that the Redistributed Manufacturing and Healthcare Network exists. Honestly, when we were starting out Field Ready in 2014, I mean, the first thing that we did was to deploy on a pilot project some 3D printers and a 3D printing expert to a medical facility in Haiti. And at the time, it was pretty lonely. Like, we had to do a lot of the design work ourselves in the field, and coming up with designs for products, sort of in real time. And the very idea that there could be a network out there of academics, no less, people actually researching this as a topic was something to dream about. The idea that this network now exists and that there is a focus on how you make high quality medical devices in the field locally at point of care is just incredibly exciting. And I'm really commend you all for your work. I'm going to set the scene with a few photographs. I don't have a presentation as such, but I'm going to show a few photos and basically talk about some of the challenges and opportunities that we need to think about when we talk about the working with making medical devices locally around the world, at least in a humanitarian context. I mean, some of our programs, a year's annual program might cost $100,000. So some of our projects and programs might cost less than a single piece of equipment that, say, the military might buy, or that a hospital might purchase here in the UK. So, being frugal, as Wendy mentioned in the opening, is important. But that isn't really what I want to focus on. What I want to focus on is the opportunities and perhaps slightly different challenges to what you might expect. If there is one photo I'd like for you to remember today, it's this one. And what we're talking about, or when I think about the issues that you are all researching and the ideas that you're exploring, I think about Ramchandra Thapa. He was a colleague I recruited in 2015 following the earthquakes in Nepal, and we took him on as an apprentice. He was a graduate, a mechanical engineering graduate engineer who'd studied in India. He'd done his final year thesis on additive manufacturing, but he'd never actually seen a 3D printer or any 3D printed object. He did his entire thesis on it, but had never actually seen it for real. And so it wasn't until the earthquake response and Field Ready's team, I went out there as my colleague, that he actually got his hands on the 3D printer. Now his business is quite a thriving business that involves, among other things, traveling around the Himalayan region of Nepal, visiting medical facilities and manufacturing on the spot spare parts and medical implements for them to use using standard FDM 3D printers. So this is a medical clinic in Sindhapalchok district. And what he's doing here is he's just knocked up a quick 3D model of a connector to a suction pump, which is a crucial piece of equipment for being able to help pregnant women give birth, and without having to go to the nearest city. So the context here is that there's power, there's electricity, there's clean running water, but it's a remote area, and it is dependent on supply chains from the Medical Supplies Division of the Ministry of Health in the Kathmandu Valley, which, quite frankly, they may only get restocked once a year. And they may not, if ever, get the supplies that they need. What they depend on for their supply chain is a nurse or a doctor or someone from the village going to the capital city at some point to see family, perhaps to attend a wedding, and bringing back supplies in their backpack. That's normally the way they get supplies. And spare parts, don't even bother, because what's going to happen is they'll have to replace the entire unit. Ram's building a business where he travels around and fixes those medical supplies. This is probably the most remote context I've ever worked in. This is in Wau district in rural South Sudan. There is no electricity, there is no water, but it's a subsistence farming community. And the reason we were there is we were working with an organization called Water for South Sudan, who were drilling a well. Now, this isn't a medical device story, but it's a spare part story. And we were able to make a spare part for them, which basically kept the drilling operation going, which could have been a very, there's all sorts of issues with getting spare parts in a place like this. The reason I'm showing it is that I almost want to put to one side for a minute the questions of where do you get the materials from and where do you get power from? I just want to get across the idea that actually the biggest challenge, I would argue, is the design skill. So the person that you see there is not someone from South Sudan. In fact, we did several attempts to recruit South Sudanese people to come and work with Field Ready, but the closest we ever got to someone with the right kind of design skills were people who were doing computer animations for TV adverts, and because they knew 3D modeling, they didn't have the engineering expertise. And so actually in this case, the design skill has been imported from the USA through the medium of an aid worker here, Ben Savanen. And actually, that's the biggest challenge. So if we can figure out ways to solve the design problem and to be able to do really good design that can then just be reused, ideally as open hardware. I'm a big advocate for open hardware. But proprietary designs that can be licensed by international organizations are also a possibility. We can find ways to run the printers, and we can find expertise to make things. Spare parts for medical devices. This is a baby warmer in a hospital. This is in a private hospital in Kathmandu, quite a busy hospital. And you're making, I don't know if you can see my video, but you're making weird and unusual spare parts. That surprisingly has a really big impact for a lot of hospital contexts. Here's a picture of Ram again. Really, this is part of the design process, consulting the community. Now, it may be that you're not always in a position to do that. And certainly if you're designing a particular product, medical device, you might be more interested in consulting the users. But there are occasions, certainly from where Field Ready is coming on, where we have to understand the problem. I've been told before that the design brief that I was given was these people with disabilities need beds in their evacuation center where they were evacuated following a volcano. That was the wrong design brief, because a bed is a solution. The design brief that we ended up following was the people with disabilities don't want to sleep on the floor. And that completely changed the product design process for us, because we actually very quickly sort of just figured out how to make raised platforms rather than something that looked like a bed. So really consulting the community and understanding the problem is part of the design process. Also, you can use traditional techniques. This is a cast metal mold, a cast metal stove burner that has been cast from a 3D printed mold. So this is combining a millennia-old metal casting technique that's been used all across Nepal and continues to be used today with 3D designs. You make a 3D print, of that, you put it into some sand, you make the negative, and then you can pour the metal into the mold. And then that is a cook stove burner, which has improved the efficiency of cook stoves by about 45%, which is enormous, because that's half as much firewood for this woman to have to go and collect. So you can look at design for additive manufacturing in a way that allows you to, even if you're not using the additive manufacturing machines to make the product as such, you can use them to make the molds that you need to make the product and use local techniques. Training local people, really important, making sure the technology isn't too weird and wonderful. If you're engaging with people, they don't necessarily know the words for the technology or for the spare parts or for the, the procurement officers who might be purchasing things don't know the words. So taking supply catalogs around with us was one of our techniques, and then people could just point at the pictures and say, yes, we're short of these, we need these products, this is what we want. I think I'm going to stop sharing some photos. These are basically all give a sense of who our makers are from Iraq, from Nepal, from East Timor. This is the inventor of that cook stove burner, actually. And there's Ram again. So you get the sense of the sort of environments we're working in and the priorities we're working on. But I wanted to take a couple of minutes to talk a little bit about the design challenges and opportunities. So as I've said, design skills are the big challenge. There can be a challenge in local skills in interpreting designs. So the more we can do to document designs and make them easier to understand, and basically not write the documentation for ourselves, but write them for other people, for different audiences, the better. Wendy mentioned working frugally and affordable technologies and approaches, but I would say that the biggest part of that is actually the ability to maintain the products. So if you're designing for an additive manufacture process and you're designing a medical device, design in a way that makes them easy to maintain, ideally by people other than the person who made it. So whether that's just putting labels on screws, or whether that's using more, rather than sort of having one single plastic block separate, printed block, you can separate it out into separate stages or something, to make it easier to anything that can make it easier to maintain is a real bonus in terms of designing for the context that we work in. Also considering waste and what happens with the waste streams. Now, we've just heard a presentation from MRHA, and from where we're coming from, me being based in London, but me being in the UK at the moment, regulation is a big deal. But in the operating environments that Field Ready works in, there may not be any regulator. There may not be a government, in fact. There is nobody to enforce the regulation. And so what we really need from designers is to basically make it possible to inform, and for the people who make a medical device, for the people who, the medical personnel who use the medical device, and for the patients themselves, to be informed and to be able to make ethical judgments over whether they want to use this locally made medical implement or not, or they want to buy the locally made medical implement or not. So we need really clear documentation. So an example that we had is that the American Red Cross wouldn't buy from Ramchandra, from his business, 3D printed tweezers like this, because they're not FDA certified. And this was in a rural area of Nepal, and quite frankly, the FDA wasn't there. that the American Red Cross was funded in America and there's high risk of litigation. So if anything were to go wrong, you know, they were worried about buying locally made 3D printed tweezers. Unfortunately, the side effect of that was that what a lot of the doctors and medical personnel had to do was to improvise. So they were using pliers from the mechanic's toolbox in place of a proper pair of tweezers, which might have been sterilized by the heat of the nozzle of a 3D printer. So it's really making it clear that yes, that this isn't the ideal situation, that this design isn't FDA certified in the case of this pair of tweezers, but my God, it's as good as, it's much safer than using a pair of dirty old tweezers from a toolbox, dirty old pliers from a toolbox, to literally spell that out about what risks people are taking, so they can inform that judgment. Now, opportunities, just briefly, if we imagine a paradigm of production where centralized quality control doesn't happen, where we have a batch size of one, where we have Ram with his 3D printer making 40 different products a day, 40 different medical devices a day, how do you regulate that process? For anyone designing these medical devices, the design has to include quality assurance embedded into the product itself. So try and find ways to build in tests, you know, the green M&M of, to use that analogy, to make sure that quality assurance is built into the design. Failing that, or if you know that isn't always possible, document the risks, being clear about the compliance, as I've said, but also really documenting the handling, the packaging, and the user requirements. You know, having a user guide as well can be really beneficial, because locally, people who make 40 different medical devices every day, they might not actually be particularly thinking about packaging and user guides and user manuals. So having all of that ready to go is really important. And then finding some way to be transparent so that the people who use these devices or need to maintain these devices can get in touch with the designers. Increasingly, Field Ready is putting QR codes on our devices so that they can use their smartphones to access a web page to get all of the instructions on how to make and maintain it, how to use it, but also to get in touch with us in case there's something wrong with the design, or they want to give us some feedback, or quite frankly, they want a replacement. But try to incorporate that in your work as well. There are some great projects I want to point you to, but I'll put that in the chat. Thank you very much for listening to me today.
That's great. Thank you very much, Andrew. Yeah, a number of things to take away from that. Actually, the sort of the need for quality in terms of robustness and reliability, and the sort of minimal resource use. Those are all sort of aspects of quality. Also, clearly, your observation that in some arenas you don't have regulation, but the lack of regulation doesn't mean a lack of responsibility in that kind of sense. And I think the last thing, and actually it's I think the POC, the point of care model that the MHRA and other regulators are looking at, actually in a few years might allow you to do exactly the thing that they didn't want to do before. And so that is, as I said to Jan, the fact that this is now coming through in a regulatory sense starts to make it all of the things that you and others are doing much more possible within a regulatory framework, which makes things great. Cool, excellent. Thank you very much indeed, Andrew. And we'll take those. Actually, and if you drop the projects of someone, we can make sure that they go into the further reporting that will come from the meeting as well. And so we now go into our first discussion section, and that'll take about 20 minutes, and then there's a kind of 10-minute break, and we'll come back to our second set of presentations, which is around medical devices.